Hello there, Wildcats. Welcome to your Algebra 1 class. And this video, I'm going to teach you about rational exponents and the properties of exponent. And also, we're going to discuss about the introduction of exponential function. So let's get started. One of the properties, or at least one of the rules in your exponent, is that if you have this is what we call now your product rule. If we have an expression here, let's say a raised to m, and then you multiply this one with the same base, make sure that it's the same base, and then different exponent, a raised to n, you have to add the exponent, copy the base, and add the exponent. So that's one of the rule, or yeah, one of the rule or one of the laws of exponent. So if you have the same base, you have to make sure that you have to add the um, the exponent. So let's get apply that rule in this example. What is the solution of 3 raised to x over 2 times 3 raised to x plus 3 is equal to 3 raised to 9? So first is using the product of power rule. So we're going to copy the base, which is the base is 3, and then we add the exponent, which is x raised over 2 plus x over 3, and then that will be equal to 3 raised to 9. Okay, because the common denominator of 2 and 3 is 6, so it will become 3, and then we have by 6, that will be 3x over 6 plus 2x over 6 is equal to 3 raised to 9. Now, because they have now the same denominator, we can now say that 3 raised to 3 plus 2 is 5x. Okay, that's over 6. So that is now 3 raised to 5x over 6 is equal to 3 raised to 9. Okay, I just want to put an emphasis on this one because they have now the same base. Okay, therefore you can now bring that down so you can solve for the value of x again, because they have now this both of them have the same base. You can now bring down this 5x over 6 and then 9, so you can solve for the value of x is equal to 9. Okay, and then we're going to multiply both sides. Okay, so we can eliminate 6. I'm going to multiply both sides by 6. When we multiply that by 6, of course, this will be eliminated. And then I have, I'll copy my 5x here. So I have 5x is equal to 9 times 6 is 54. And then I'm going to divide both sides by 5. Okay, I'm going to divide that by 5. So the value of x here is equal now to 54 over 5. Therefore, the solution, okay, because the question is what is the solution? So the solution is 54 over 5. So that is our first example. All right. Next is we're going to apply the power of power property. When we say power of power property, you have to multiply two exponents with the same base. We have to make sure that the given have the same basis. Okay, so to generalize that, the power of power property says that the quantity a raised to m raised to n, so there are two exponents here, okay, is equal to a raised to m times n for all integers m and n. Take note, the difference between the product and power of power is that On product, you have two bases. Okay, you are multiplying two the same bases with different exponent. In here, you only have one base with two exponent. Okay, they are actually enclosed with a parenthesis there. Um, for us to understand that further, we will be doing this example, which is what is the solution of 27 x minus 4 is equal to 3 raised to 2 x minus 6. Again, um, one of the most important thing is that we need to look at the bases. Okay, and how are we going to rewrite 27 and 3 so that this will become on the same base? All right, so we have to think about that. All right, so let's start with the product property. All right, so it seems that 27, if I put 27 here, will be 3 raised to 3, right? Because 3 times 3 is 9, times 3 will give us 27. And then we still have that exponent here, which is x minus 4 is equal now to 3 times 2x minus 6. One of the most important again is that they need to have the same base. Now, in this case, they don't have the same base because this one is 27, this one is 3. We need to take a look at the divisibility rule of one of the number. So 27 is divisible by 3. So 27 is divisible by 3, so we have 3 raised to 3. And then we still have to keep your x minus 4 exponent. And then after that, we have to distribute to your 3, which will become 3 raised to 3x. It's the exponent 3 minus 12 is equal now to 3 and then 2x minus 6. So as you can see on this part, they have now the same base, which is 3. I'm going to highlight that again. You can now bring this down, 3x minus 12 and 2x minus 6. So we can solve for the value of x. Okay, so that's the objective there. Make sure that both side of your equation have the same basis, so you can bring it down. So I have 3x minus 12 is equal to 2x minus 6. Now from there, it's like solving simple linear equation in here. So we have subtract 2x both sides, subtract 2x. This will become x minus 12 is equal to negative 6. I'm going to add 12 both sides. Of course, this will be cancelled, so you have x is equal to 6. Therefore, the solution here would be x is equal to 6. Okay, next. What is the solution of 1 over 125 raised to negative x over 2 is equal to 1 over 25 raised to negative x over 3 minus 2? Okay, first is the first step here. Okay, this will be a lot easier. So step 1 is that rewrite the equation so both sides have the same basis. So how are we going to do that? We also have the negative exponent rule. It says that your negative exponent rule says that any number raised to a negative number, that will be equal to 1 over a raised to the positive exponent here. The same way that if your number or your expression is written in 1 over a raised to n, it will become the exponent is negative. So from here, I have 1 over 5 raised to 3. This one is 1 over 5 raised to 3, close that, and then the exponent x raised to 2. And then this one is 1 over 5 times 5, 5 squared is 25. And then the exponent x over 3 minus 2. All right. And then I have to rewrite this one in such a way that I have the same basis. Okay, so it will become, because this is positive, it will become negative. So 5 raised to negative 3, and close that, I have negative x over 2 is equal now to 5 raised to negative 2. I'll close that, and it will become negative x over 3 minus 2 as the exponent outside. So from there, I can um, write the expression or the exponent as an equation and solve. So what I'm going to do is it will become negative 3x or positive 3x over 2. So become 5 raised to negative 3 times negative x will be 3x over 2. Okay, that's an exponent. And then the same here, we have negative 2. It's distributive property. Negative 2x because, or positive 2x, I'm sorry about that. So it would be positive 2x over 3 over 3 plus 4 because 2 times 2 is 4. So I have 2x over 3 plus 4. Then again, because they have the same exponent now, I'm going to bring down this one. I'm going to rewrite the exponent as an equation and we're going to solve. So I have 3x over 2 over 2x over 3 plus 4. So I'm going to multiply both sides with the LCD of 2 and 3, which is 6. Okay, so it will become 6 times 3, which is 18, divided by 2 is 9x, is equal to 6 times 2 is 12, divided by 3, it's 4x plus 24. And then I'm going to subtract 4x both sides, subtract 4x. Okay, this will be cancelled, so 9 minus 4, I'm going to put it here. 9 minus 4, it's 5x, is equal to 24. I'm going to divide both sides by 5. So the value of x is equal now to 4.8. So the solution is 24 over 5, or x is equal to 4.8. All right, next one. So those are your rational exponent and properties of the exponent. So just to give you a review on that, we did one of the property is your product rule or product property, and then we have the negative exponent rule, and then we have your power to power rule, right? Now let's proceed with exponential function graph. All right, so let's take a look at the this example here for the key features of f of x is equal to 2 raised to x. So question A, what does the graph of f of x is equal to 2 raised to x look like? Okay, so the table shown here, if you are going to make a table of values, we have to put a designation on the values of x. So any number or any real number, you can put in the values of x, okay, and then plug them in as an exponent here. So we have negative 2 value of x, or negative 2, negative 1, 0, 1, 2, 3. When you plug that in, it will give you measurement of or the value of y, which is 1/4, 1/2, 1, 2, 4, and 8. So if you go and graph that, as you can see here, um, as x values approaches, okay, as x values approaches your negative infinity, y values approaches 0. And also the y-intercept here would be 0 and then 1. So that will be your y-intercept there. Okay, so what else can we say about this graph? So let's take a look at this question here. It says there that we have, what are the characteristics of the graph of f of x is equal to 2 raised to x. The graph of f of x is equal to 2x is a continuous between and beyond the x values, shown so that the domain is all real number. If you can see here, the domain is all real number. It is because, so every single values of x has a designated partner for us to the range of it. Okay, so there's the values of x. The function get closer and closer to the x-axis but never quite reaches it. When the function approaches the line in this manner, the line is called an asymptote. So if the line is an asymptote in this, okay, in this example, the domain is or the range, because the domain is all real numbers. So the range here now is y is greater than 0. So there is no negative range in this example that we have. Okay. Now let's take a look at this one example here. So we're going to graph exponential function. I want you to listen to the problem and let's solve and graph this one.
A network administrator uses the function f of x equals 5 to the power of x to model the number of computers a virus spreads to after x hours. If there are 1,000 computers on the network, about how many hours will it take for the virus to spread to the entire network?
All right, so the initial amount is just one computer, and it says there that the function of x is equal to 5x, 5 raised to x, I'm sorry. So let's take a look at the solution. First is you have to make a table of values. So at 0 hour, it has one computer, and then after an hour, we have 5 computers. After 2 hours, we have 25 computers infected. And then after 3 hours, we have 125 computers. After 4 hours, we have 625 computers. And then after 5 hours, we have 3,125 computers. Now, the question there is that how many hours will it take for the virus to spread to the entire network? So if there are 1,000 computers. So if there are 1,000 computer, so that is approximately in between 4 and 5. Okay, because after 5 hours it has 3,000. So they only have 1,000 computer. So that is one of the analysis that we will be looking at. So let's take a look at when, okay, at what hour, at what time did the virus is spread to the entire network that has a 100 computer. So if you graph the function, you can see here that when y is 1,000, that is by estimation only, it's about 4.3 or 4.5. So let's take a look at that. So 4.3, about 4.3 hours. So in step 3, you can use our calculator and put 5 raised to 4.3. That is about, or that's around 1,000, 1,012. So which is close to 1,000. So maybe I can try 4.2. So if we have 5 raised to 4.2, it can be 862. So 4.3 is the closest to our answer there. So our conclusion is that it will take the virus about 4.3 hours to spread to the entire network. So if you will encounter this type of problem, first is we have to take a look at the um, or we have to make table of values, and then you have to graph, and then use your calculator to check your graph if it is correct or what. All right, so that's another example that we have there. Now that we did the graph of exponential function, and we say that the graph of an exponential function is an asymptote. This is now the concept of exponential function, and we'll go and dive in more as we go on with exponential function as a lesson. An exponential function is the product of an initial amount. When we say initial amount, it's the a here. So this is the initial amount here, which is the a, and the constant ratio. When we say constant, it's stable, raised to the power. Exponential function are modeled using f of x is equal to a b raised to x, where a is a non-zero constant and b must be greater than 0 and b must not be equal to 1. Okay, so let's I want you to screenshot this one, and then as part of your note, or you can pause this video and then copy this concept of exponential function. All right, so let's take a look at this two example here. If we are going to write a exponential function based on graph and based on table, so what is the written form of a function represented by a graph? Remember, f of x is equal to a times b raised to x, or ab raised to x. This is the initial. So when we say initial, it is when x is equal to 0. Okay, so what is the initial amount here? The initial amount is 4. So 4 is the initial amount. Initial amount. Now, the initial amount is 4, and then let's take a look at the constant ratio. What does it say there? This 4 and 12. What does it shows like a constant ratio? Let's see. So 4 and 12 is 12 divided by 4. Let's check this one. Is equal to 3, and then 36 divided by 12 is also equal to 3. And then let's check this one. 108 divided by 36 is equal to 3. And then the same with 324. Divide that by 108 is also equal to 3. Therefore, the constant ratio, okay, the constant ratio is equal to 3. So we can now write the exponential function as f of x based on the table f of x, the initial amount, which is 4. Okay, I'll just close this one with a parenthesis, and then the constant ratio, which is 3 raised to x. Okay, or you can write this one as f of x is equal to 4 times 3 raised to x. There. So either of these two is accepted as part of the as a written formula for this table. So the function is f of x is equal to 4 times 3 raised to x. How about this table here? So what do we think is our initial function or initial amount? Your initial amount, the initial amount would be when x is 0, we have 128. The initial amount is 128. So take a look at when x is 0, what will be the value of y, or what will be the function? So 128. So take a look at the y value, 64, 32, 8, and 4. What do you think is so let's see, 4 divided by 8. This one, 4 divided by 8 will give us 1/2. 8 divided by 32, 8 divided by 32, which is also 1/2. 32 divided by 64 is equal to 1/2. And 64 divided by 128 divided by 1, divide this one by 128 is equal to 1/2. So our constant ratio, so the initial amount there is 1/2. We already have the initial amount is 128, and the constant ratio, I'm sorry about that, is 1/2. So we can now put as f of x is equal to the initial amount 128 times the constant ratio, which is 1/2. I'll just close that and then raise to x. This is now your exponential function based on the graph that we have. All right, so there you go, guys. If you have any question about exponential function, this is just only an introduction of the exponential function. So we'll go deeper in understanding graphing and analyzing graph, writing an equation based on table and based on graph of exponential function. So we'll see you in the next video, guys. And if you have any question, don't hesitate to reach out, email me, um, any form of communication that we have. Please stay connected, guys, and we'll see you in the next video. Bye bye.